we try to have a more professional way of design, although to generate a 50% or 30% duty cycle square wave is quite straightforward. Okay, so let's look at the questions. Okay, so you are required, to develop a timer by using timer and interrupt. Okay, by using timer and interrupt, prefer one timer, write a program to generate a single tone system wave as below in one single program. 50% duty cycle and 30% duty cycle. Okay, so this is the requirements given to you. Okay, so whenever you come to any design, you have to these few things you need to make sure that is with you. So the design requirement and specification. Okay. So class, you might say that all these steps are unnecessary. Yes, it's unnecessary if you design a simple program like this. So if you have a very complex program, let's say for example, you work in groups, or you already graduated and go to industry, you work as a team. So therefore, at that time, design requirement and specification is something that is very, very important. Okay, so in design requirement and specification, we have something called user requirement. Okay. So under user requirement, actually, user requirement is what I call that is an end user what the end user needs. Okay, so over here, what is the end user needs? He just want to have a 30% and 50% duty cycle of signal to be generated. Okay, so these are the end user needs. Okay, no matter what is going on, this is what they want. They don't care what kind of tools you're using. They don't care what kind of language you're using. They don't care what kind of hardware you are using, but they just need the end product. So something that can generate 30% to 50% duty cycle. So these are the user requirement. Okay, so basically it's the end user needs. Okay, so you have to make sure that you copy down everything, before you start design, to ensure that you don't have any mistake. Okay, so let's say once you are discussed with your customer, okay, so the customer agree and you are agree, then you have to put down your signature and your company stamp, okay, to ensure that they don't change their mind. So, okay, let's say agreement is reached. Okay, how much is the payment? Okay, example. So then only you move to the second step. After the agreement is met, then you move to the second step. So second step basically is a functional requirement. Okay, what is a functional requirement? So functional requirement, actually you go back to your team. Okay, so you already discussed with the customer. You go back to your company and meet your team. So this is basically you are telling your team what the system must do. Okay, these are the functional requirement. Let's say, for example, okay, you say that the user want to have a 30% and 50% duty cycle. Okay, so this is a 30%, so this is a 50%. Hey, sorry, my drawing is not good. Okay, hold on. So these are the 30%. So this is a 30%. Means 3, 7, 3, 7, and so on. So this is a 50%. So 5, 5 example. Okay. So at that time, the user didn't say that what is the period. So you may come up with your own period. Okay. Let's say, for example, to make things easy. So we discuss among your team. Say, oh, let's say it's a 10 millisecond. We'll coming back to we send this idea to the user whether they agree such that the period to be 10 millisecond. Okay, so it can be 4 millisecond, it can be 20 millisecond. So it's up to what the user requirement. Okay, but at that moment during the discussion, the user didn't mention anything about the period. They just mentioned about 30% or 50% of duty cycle. So then come to the tree. Then you have to look into the system requirement. Okay, so system requirement basically is what I call that a building block. You know, a building what I call that a building block. Okay, I'll write down. You know, a building block. Okay, for to develop the system. Okay, let's say for example under the third. Hold on, I don't have enough space. How to going down? Go down. Okay. So here in the system requirement, probably we already identify what kind of microcontroller you're going to use. Okay, so in here we are probably using microchip. Okay, so it depends on the respective company. So that company, let's say a company already quite established using microchip, then you should move on with the microchip and identify the respective IDE. Like for example, today we are going to use MPLAB X, and we're going to identify the appropriate C compiler. Let's say, for example, we are using XC8 if we are using PIC18, or XC16 if you're using PIC24. Okay, if B company, they are using 8-bit microcontroller like AT89S8252 or any other microcontroller, then they have to search for the appropriate IDE. Okay, let's say for example, if I'm using Atmel, probably I can choose Microvision. Okay, or if I'm using STM32, I also can choose Microvisions. And of course, here is where we discuss what kind of tools and what kind of hardware you want to use. And of course, now 30% and 50% is just a simple design. So we don't even need PIC18 or PIC24. Okay, you can use just a simple microcontroller, probably a 4-bit microcontroller, PIC12. Okay, so nevertheless, here is where we are looking into more details, the detail of our microcontroller, the detail of the system, the details of the tools that we are going to need. Okay, so these are what is the system require. Okay, is it okay so far? If yes, give me a thumbs up. Yep. Okay, great. Okay, so these 3 steps is very, very important. Okay, so and also probably over here we already, after you discuss with the software engineer, probably you know that, or I need to involve a timer, and I need to involve some interrupt, to make the system more appropriate. Okay, and we are not going to use a delay. We are not going to use pooling, for example. I hope that all of you can differentiate between pooling and interrupt. And class, remember, doesn't mean that every situation you want to use interrupt the answer. Okay, so sometimes pooling is equivalent important. Okay, it depends on the requirement. Okay, why? Because interrupts are limited in every microcontroller. Don't simple or some simple situation you also try to use interrupt. Okay, so then the number 4, actually the final is a system specification. Okay, when it comes to system specifications, where we decide, we draw our microcontroller example. Let's say my microcontroller. Okay, then okay, what is the input? Okay, what are the output? Okay, that's we require. Okay, okay. So and then so it's a best place where we're using a block diagram. Okay, block diagram to give a clearer picture. Okay, of your design. No, to give a clearer picture of your design. Okay. Okay. So probably here is where you have a meeting with your friends, a meeting with your team. So you draw out the layer, and these are the system specification. Okay. So and here also we also go a bit deeper. Let's say if I'm using timer, using microcontroller PIC 18, I'm using timer 0. So what kind of register will be involved? Example. Okay. Just a simple discussion. If I'm using interrupt. Okay, what kind of interrupt? Let's say INT0 or etc. or timer interrupt. Okay, ET0 or something like that. This is what you should discuss in the system specifications. Okay. So after all this is done, then it's up to your team whether you want to draw a flow chart or you want to draw what I call that pseudocode. So it's up to you. Up to your company. Okay, so flowchart is the flowchart or pseudocode actually is to help your design to be more fluent. Okay, so remember, flowchart doesn't mean that it have to be 100% accurate. They might have some mistake, but this mistake shouldn't be very prominent, shouldn't be very obvious. Okay, so that's why you are it's important to have a very effective flow chart so that everyone can follow. Okay, so this means that, what do you mean by effective flow chart? Effective flow chart means that some ordinary people, let's say when you draw a flow chart, you ask your friend able to understand what is that, then this is what we call an effective flow chart. They got two types of flow chart. One is a layman flow chart. Another one is a technical flow chart. So no matter whether it's a layman flow chart or technical flow chart, so you have to ensure that the user, your team, able to understand what you are drawing. Okay, so let's say, for example, if layman flow chart, when you draw that flow chart, when you ask your little younger brother who is studying in secondary school, they're able to explain, what is that, what are able to explain, the flow of the chart. So whereas for the technical flow chart, you can ask your friends who are in this area, they can able to let you know how this thing works. Remember, flow chart shouldn't type with language. Okay, so once you draw the flow chart, that flow chart can be used in any language, whether it's Python, whether it's C programming, whether it's a Visual C or C++ or C# or etc. Okay, so let's come back to the questions. So the question said that, very simple, I want to generate 50% duty cycle and 30% duty cycle by using one timer, prefer one timer. So of course, we're not going to use two timer. It's waste because timer is also something that is very, very important, very, very in design. So you don't want to waste another timer, okay, as well as interrupt. So then we come to our design. So before we come to our design, first thing we should look is the data sheets. So therefore, we have to move to the PIC 18 data sheets. I think you have all this folder. So and we are today we are choosing 18F4550. So class, remember I will teach you how to read data sheets, but of course you are not reading from page 1 till page, how many pages over here, I'm not sure. It's so many pages over here. We just read something that is important. Okay, so when it come, okay, let's come to, if you want to do hardware construction, we should, first thing we should look actually is electrical specifications. It's over here, DC and AC electrical characteristics. It's very important when it comes to electronic constructions. Let's say you want to connect LED, want to connect the switch, whether what is fan in, what is fan out, all these things is part under the these electrical characteristics and the DC and AC characteristics. Okay. But if you're the new user, definitely is the first page is the one you have to look into to identify how good is this microcontroller. Okay, whether all this memory suits you, whether it's appropriate microcontroller for your design. Okay, of course, as I told you just now, we do not need such a powerful microcontroller for this simple program. You see, yeah. Let's say if we pick 18F4550, look at flash is 32K. We don't even need 32K. Okay, here are some of the features. You know, they come with this microcontroller. Normally, it's always in the first page. And the beauty of this microcontroller, because they're using a nanowatt technology, so it means that it can consume. You don't use up much battery, okay? But again, nowadays nanowatt is nothing new, okay, for information. But today we are touching something on timer. So immediately we just look into the timer, okay? So before looking at the timer, the most important thing is this beautiful block diagram, okay? So let's look at this block diagram, and I myself believe that most of you already quite familiar with PIC 18 timer. If yes, give me a thumbs up. No? If no, say no. Okay, so quiet. Oh, okay. Anyway, so class, it doesn't matter whether what kind of microcontroller you are using, okay? Let's say, I'm switching to PIC 18 and PIC 14, PIC 24, PIC 32, or my Python or not Python, to STM32. So you just need to learn how to read this particular block diagram. So just look at this block diagram. You look at here. So this is a multiplexer. I hope that you know this symbol is multiplexer. So you can choose between 0 and 1. So because this block diagram already show you a lot of things, you don't even need a reference book, okay, to let you know what is going on over here. So let's look at this block diagram clearly. Okay, so first of all, ouch, how to remove this? Okay, hold on, sorry. Okay, so first we have two selections for you as an input to give the brain, to give a tick, for the microcontroller. First is using the internal, the clock, okay, the FOSC divided by 4. If you're using crystal, then you're using, let's say if you're using 8 megahertz, means it's 8 megahertz divided by 4, okay. Let's assume today we are using 10 megahertz, make it a bit fun, okay. So let's say we are using 10 megahertz, okay, then it's so the crystal clock is a 10 megahertz divided by 4. Or you got the input signal is coming from the TOCK1 pin. So since we are not measuring the period of the input, okay, so but however we are generate some signal, so that's the reason we are choosing this FOSC divided by 4. So we are using 10 megahertz, okay. Is it okay? So let's say, for example, if I'm using TOCK pin and we have a TOSC, TOCS, and all this pin over here, so TOSC. So let's say you don't know what is TOSC, you can always go back to the special function register. Let's say TOSC means 1 is increment on high to low transition. 0 means increment to low to high transition. What does it mean? So this means that if you connect this to a signal. The signal is coming in. So whether it's high to low, we incremented by 1, or low to high is incremented by 1. Okay, so now we don't bother about this because we are not looking into TOCK1. Okay, so therefore we choose the external frequency. Okay, FOSC divided by 4. Okay, whether it's external or internal, we are using the oscillator frequency. So then we come into here. Let's say we choose this. We come into here. This is a prescale. So prescale is basically just to what I call that. Prescale basically is just to reduce the frequency. Okay, let's say for example, if I'm using 10 megahertz, so 10 megahertz, yeah, by 4. I hope there's a paper with you. So it's equivalent to 2.5 megahertz. Okay, let's look at the top S2 and top S0. So top S0 is a prescale value. It just, if I choose 0, 0, 0, it divided by 2. So let's say, for example, if I choose 0, 0, 0, 0, 0, so 2.5 megahertz, basically, it just divide by 2. It gives you 1.25 megahertz. Yeah, megahertz, okay? So class, you see, this diagram is very useful. You are already, I think you can guess what is going on. Okay, then the PSA, PSA is determined whether you want to use the prescaler or not the prescaler. Correct or not? You see, this prescaler is we can choose between 0 and 1. If I choose 1, so this means what? Means what? We are choosing the FOSC 4 and without prescaler. Okay, so then this one is the delay. Remember, nothing is perfect. Even though you're using a timer to generate 1.25 microsecond, it wouldn't give you exactly 1.25 microsecond. They got plus, minus. Okay, the accuracy is not 100% exactly what you want. It's just a plus, minus, probably 2 to 3 microsecond. So this one actually is to this is to sync with the internal clock. Okay, so then whatever happened here will increment or decrement the whatever value is set in the timer 0 and timer high byte and low byte. Okay, the high byte is here and low byte is here. Okay, what does it mean? Let's say if my value inside here is 1, 2, 3, 4. So every time there's a ticking, this will be increment 1 by 1 until he reach F. Another tick is coming in plus 1. Overflow will be occur. When overflow occur, the TMR 0 in overflow, timer overflow will be set to 1. Okay, is it clear? Not clear. So no means what? Okay, so class, I repeat. I think just look at the example, is quite straightforward. Okay. There are 2 options. One is external. You want to measure the external tick. Let's say, for example, normally TOCK1 is for counter. Let's say I want to identify how many people is entering into the library. So every time high to low, then this you incremented by 1. Okay, this is incremented by 1. Okay, if we are using this, whenever there's a tick, this will be incremented by 1. Okay, is it all right? Okay, so then if this will, when this reach F, incremented by 1 again, overflow will be set. So this means that the setting of time is already reached. Okay, so remember, when the overflow is reached, this will go back to 0, 0, 0, 0. Okay, if you have a predefined value earlier, you should set back, should reload back the value that you want. Okay, without delay, let's look at the example. I think it'll be more clearer when you look at the example. Not example, look at our design. Okay, we draw the flow chart. So before I draw the flow chart, because this time we are using the interrupt, let's go to the interrupt. So class, before we move to the interrupt, any questions on timer 1 or timer 0? So basically timer 0, timer 1, you know, more or less it's the same, you know, by just looking at their block diagram. Is it all right? Yes, any questions? Any questions from the floor? Why so quiet? If no question, give me a thumbs up. Why so quiet? Yes, any questions? No questions? Okay, no question, then we move on. Okay, I hope things is clear. So let's look at the interrupt. So there are so many interrupts over here. Okay, so, and if you are quite familiar with peak 18, so basically in peak 18, the interrupt, they have a higher priority and lower priority. Okay, so you see, by looking at this table, we already know what to do. Okay, so let's say, for example, you look at towards, there are so many interrupt over here. Okay, let's say you are choosing timer 0. So this is a timer 0 interrupt. So these are the timer 0 interrupt. So whether you want to give the timer 0 to be the high priority and lower priority is up to you. Okay. Okay. So, but in the end, in order to activate any interrupt here, you have to activate the master interrupt. The GIE have to be on, have to be 1. So if this is the low priority interrupt, this one need to be on. Okay, all these things need to be on in order to activate the interrupt. Let's say if timer overflow is activated, is all gate, 1, or if anything is 1, and provided GIE is 1, then interrupt is only be activated. Okay, is it okay, class? So if you choose the higher priority, this will become 1. Let's say this is activated, become 1. 1 becomes 0, so therefore the low priority will not be activated. So this is a very straightforward, okay, you know, for the interrupt. Okay, so the more detailed interrupt, just go through some of the explanations, you know, in these data sheets. Okay, so if you understand the timer interrupt, then it's a time for us to draw the flow chart of our design. Okay, let's say how to draw appropriate flow chart. So I hope that this flow chart able to make you understand what is going on. Okay, class. Now my question is, okay, so still remember just now we are using peak 18. These are the system specification just now. Still remember, we already, the system requirement, we already decided is the period is 10 milliseconds. And 30% means 3 milliseconds. 70% means 7 milliseconds. So this is what we should come out, you know, in our system specification. So we also have a 50% here, 5 millisecond, 5 millisecond. Okay. So you must remember, if I'm using 10 megahertz, okay, so 10 megahertz divided by 4, so basically it's 2.5 megahertz. So this means that it's actually equivalent to 2.5 is 0.4 microsecond. Okay, so this means that it's not possible for me to generate 5 millisecond, correct or not? Because the microcontroller is very fast. So it's possible for me to generate 1 millisecond. Let's say I want to generate 1 millisecond. Okay, So I have a counter, count 3 times of 1 millisecond, then I toggle. I have a counter to generate 1 millisecond and 1 millisecond, and a counter count 5 times and toggle. Okay, so these are the information that I have. Okay, is it all right? So if yes, give me a thumbs up again. Is it clear? Class, you're not clear, please let me know. Okay, switch on your beautiful mic. Okay, if yes, let's draw our flow chart. Okay, so it's very simple. So how to draw a flow chart? So I know that I start. I can do some initialization. Okay, of course, this initialization is depend on what microcontroller you are using. Correct or not? You want to set the timer, we need to set the appropriate register. So these are the initialization. So then let's say initialization set the timer. When interrupt occur, so these are the timer interrupt switch routine. Okay, so back to this. Okay, before I back to this, can you tell me how to generate 1 millisecond? Basically, let's come back to this. Come back to timer. Up to you which timer you prefer. Or probably you want timer 1 or timer 0, is all up to you. Okay, so basically, in order for me to generate this 8-bit mode means 8-bit only, now it's 16-bit. In order for me to generate 1 millisecond, what should be the value in the timer 0 low and timer 0 high? So if I want to generate 1 millisecond, so what should be my TMR 0 high? What should be my TMR 0 low? So this one makes basically is a 16-bit. So maximum is FFFF. Okay. How means that when I reach 1 millisecond, interrupt will be occur. So what should be this value in order to generate 1 millisecond? Given such that we are using 2.5 megahertz, okay, means 0.4 microsecond per tick. How many tick, I should run, remaining ticks to run in order to trigger an interrupt? Do you get what I mean? So it's very straightforward. Okay, FFFF plus 1 means that this FFF plus 1 to trigger an interrupt means 65536 minus what value? Multiply by my 0.4 microsecond is equivalent to 1 millisecond. So what is this? Okay, you have calculator. Can you get me the answer? Yeah, come on. You got calculator with you? Come on. I need to search for my calculator. Where's my calculator? Okay, using my handphone. So what is the value? So you need to calculate. Okay, so the value should be 0xF63C. Am I right? So this means that if I put 0xF63C over here, so let me erase all these how to clear all these things all together. Delete. Okay, so if I'm using F63C here, and then I'm feeding in about 2.5 megahertz. So I will calculate F63C will calculate until FFFF plus 1. then I will trigger an interrupt. So what is the time here? The time here should give you 1 millisecond. Because each tick is about 0.4 microsecond. So if you don't believe me, your FFFF 65536 minus F63C, okay, then you will give you about 1 millisecond by multiplying with the 0.4 microsecond. So this means it run until here, then the interrupt will be occur. Yes or no? If no, say no. If yes, just say yes. It's very straightforward. Okay, how about others? So I need to ensure that everyone got it, you know. It's very straightforward. So this is how we calculate time. You know, this is a conventional method, auto reload method. Okay, but however, there's another method over here by using a compare. Why is not here? Using a comparator that is much easier. Okay, this one is putting in the value here and compare the value is the same, then only the interrupt will be triggered. Okay, we don't talk about this first. Timer 2, we talk about timer 1, we talk about auto reload mode. Okay, so if everyone is clear, then we draw our flowchart. Okay, so class, remember, don't put this value into the flowchart. Okay, because this one is just applicable if you are using 10 megahertz. So flowchart shouldn't reveal all this information. Flowchart by right is universalized by all microcontroller, regardless whether it's PIC 18, PIC 24, or microchip, or STM32, or Infineon, or blah, 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 okay? So if you know that, no matter what is going on, when an interrupt is happening, okay, let's say after 1 millisecond, we need to reload the timer. So, and as you know that, we need to clear the interrupt overflow. Or clear the timer interrupt, or timer interrupt lah. Okay. Why? As you know that, after 1 millisecond, you will set the interrupt. Then we need to reload back F63C for the second round, because they don't know how to reload by itself. So again, auto reload is depend type of microcontroller you are using. Okay, so you don't know how to reload itself, so that's the reason you need to reload it. Okay, so this is more universalized. Then after reload, I think I should I should increment the count. Increment count means count plus by 1. Means count plus okay. So then we have something, a condition. Okay. Is it count equal to some value? Let's say, is it count equal to 3? It's 3 millisecond. If yes, then we should toggle the 30% pin. All right. If no, then you have to check again whether the count equal to 5, 30% toggle 30%. If 5, then I will toggle 50% pin. Okay. So this is yes. So Then if no, is count equal to 10? Okay. If yes, not enough space, I put a colon here. If no, I put a colon here, colon 1, colon 2. It's a connector. Okay, it's up to how you draw it. Okay, so same if toggle 30%. If okay, after that, you know you should connect it. Probably we go to the connector tree. Okay. So let's continue. Let's count equal to 0. When count equal, if count equal to yes, what happened? Then you have to, let's say connector 2. If yes, then if count is really equal to 10, means it's already completed. If completed, we have to put back, you know, the 50% back to high. It's up to you, this one, up to 1, and the count is back to 0, correct? We calculate everything again so they can repeat for the second cycle. Okay. Okay. Is it okay? So then this is to return to interrupt. Okay. If no, it just directly come into here from 1. Okay. So return to the interrupt. All right, not? If count is no, it's not equal to 10, that's is returned. We're only running this if the count is equal to 10. Okay, so how about this, the tree? So same, the tree actually is return to interrupt, correct? So we want to repeat until it's reached 10 times. So these are my flow chart, you know, of this design. Okay, you might ask, better immediately write the program lah. Yes, I agree with all of you. If you have a very simple design, yes, for this, yes, you say, oh, your drawing flowchart is very mafan, correct or not? But remember, so if this flowchart, I bring it, you know, to a secondary school student who start using programming, don't you think that is helpful? I'm not sure lah. Probably it's more suffer. They look at this flowchart. So it's so straightforward. You see, timer interrupt, reload the timer, clear the timer, flow interrupt, increment a counter, count equal to 3. Okay, blah, blah, blah. So I don't know whether I miss out something or not. Okay, probably I need an arrow here. So, okay, come here, come here. Okay, come here, come here. Okay. So it's just to end the things up. Yeah. Okay. Is it okay, class? So if all this thing is okay, so one more thing is toggle 50% also gone. So the toggle 50% actually here is still cannot be, there's no ending here. It also should be continue. I believe that these are sharing with 3. Okay, let's put eraser here, erase this. Okay, it's also going down 3. Okay. So let's look at the design. Okay, so this is our design class. Whether is it correct? I'm not sure. But for me, flowchart is just a guidance, for you to type your code. Okay. Is it okay? Okay, there's a question where you got 65536 from. Yeah, yes, yeah. Cheng Sheng, you very good. You answered the question for Mensing already. It's a 65535 plus 1. Why plus 1? Because that is when interrupt is occur. Okay. Because it's 16-bit, 16-bit maximum is FFFF. So plus 1 means its overflow will occur. Okay, when overflow is occur, he will trigger that interrupt. Okay. So now it's a time to type your program. So then you need the MPLAB X. Okay. So everyone is okay or not? So if okay, then I will go to the MPLAB X, the file, new project. slow, you know, once I on all these things become very slow. Okay, let's start with PIC 18F4550. So we only thing we can use is simulator. Next, okay, X8. So I browse my design. I don't want to store over here. I want to store into my download. Okay, so many things here. Pre-lab. Okay, open. Okay, and then I say, remember, give him a nice name also. Okay, duty 50 30, so that you know what is going on. Okay, the project finished. Okay, this is a duty. Okay, then we need to put in the source file. Okay, source file, new file. Okay, we are using C programming. Give me a source file. Next, okay, duty, give me duty 50 30. Okay, so finished. Okay. So is everyone okay? So now is a time to write your program. So, okay, step 1. So when you write, because now is you're using PIC 18 microcontroller, so you need a header file. As usual, our header file will be then of course we need to come back to our system specification. Okay, just now, you know, we don't need to let the user know in the system specification the input, the output. So which is the output pin that we want to choose. So it's up to you. Okay, let's look at the PIC 4550 microcontroller. Okay, then come back to this. Sorry, I told you that this class you need to do a lot of movement. This is the pin. There's so many things over here. Okay, so beware, if you're using analog pin, you need to set the analog to be digital so that you can use the RB4. Okay, so let's choose somewhere. There's so many input output pin here. Okay, I prefer RD port D because port D don't share with analog pin. Okay, so this is why I choose port D. Okay, so in order to easy, you know, I just choose pin 21 and 22. Okay, because 21 and 22 don't share very much, you know, with a lot of functions. Like if you choose RB4, you know, they're sharing a lot of function. Okay, there are a lot. It can be analog pin, it can be other things, you know. Okay, so that's why I choose 21 and 22, RD2 and RD3. Okay, so I choose RD2 to generate 50%, 3 ma 3, 30%, RD3 as a 30%. Okay. Yeah. And also class, you have also the concept such that we latch the output, we read the input. Latch is output, read the port. Okay, when you latch the output and you want to doing something nice, then I should define, you know, I define my duty cycle. See, I put it nicely. 50% is actually equivalent to LATD2. Okay, so same thing, copy and paste. So this is a very good way of writing code. So that's why I know that when people don't even need to read, you know, your program, you know that, oh, duty cycle actually is a port RD2. Duty cycle 30% is RD3. Okay, remember, we are not writing RD because what? Because we normally latch the output. We only read the port. You know, if let's say it's a switch, then we reach the RD2. And probably you want to make things more interesting, you know, I can, like, for example, I can define one more thing to show that I want to connect to a switch, okay, a switch, okay, or sometimes you also can write RD4 or let's say RA0 lah, it's not RA0. Let's choose where is RA0 is. RA0 still is not shared. It's sharing analog. Okay, you have to set the analog pin and therefore be careful. Okay, let's make it not be careful. Okay, so you can do something like this, or you know, if you're not sure, you can do something like this as well. Port A bit dot. Why not coming out? Port A bit dot, correct? No, why not coming out? Okay, never mind. We just choose this as a RD4. Okay, so we don't use this first. We blank code this first. We use it later. Okay, then we must have our main program. It's up to you. You know, if type void it's up to you how you do it. Okay, then you have to all these things. Okay, so go back to our program also that. Our flow chart. Where is our flow chart? I hope I'm not going too fast. Okay, so initialization. When start, we should initialization. This is the main program. So we do initialization. So in order to do it nicely, we don't simply type initialization over here. So probably you can type give him a function, IO input output or something like or just type initialization. Initialize. So we got give him a function. So initialize, you just declare it as a header file. Okay. Okay, then we type our initialization function. Okay, so what should be initialized? Of course, if you're using LTD port 2 and port RD3, so the directions, you know, still remember it should be have a output. So this means that your tries D2 is an output, tries D3 is an output. Okay, so okay, tries D2. Okay, so let's say if sometimes you're not sure what kind of whether you are typed the correct reserved word or not, you can always navigate the declaration from here. Yeah. Where is it? Chip select. A lot, long journey. That's why very mafan one, you know, big thing. F4550. Where is it? Wow, don't have I miss it. 454. Okay. If you can't find, then search. Here is it. Okay. And navigate. Okay, just close all this not related. Okay. So these are the header file. Okay, let's say for example, we are not sure whether is it tries D2 or not. You just copy this and find whether they got such thing. Okay, it's correct. Tries D2 is okay. So it's declared. It's being declared well. RD2, all these things being declared. Okay. Okay, it should be dash. Means this one should be dash just now. Okay, is it all right, class? So what else? Okay, the duty cycle. So this is optional since okay. At the very beginning, the duty cycle 30 should be equal to 1. The duty cycle 50 must be equal to 1. Okay, so it's high at the very beginning. Okay, so then that's all. That's all for the initialization. Let's say IO. IO for IO. Input out initialization. Okay. So then you also have after we initialize the input output, we also should initialize the what I call that the timer. Timer initialize. Okay. Same thing. Put it over here. That's the header library. Okay, so we have timer initialization for our library, for our timer. Is it clear? Don't worry if you can type with me, you can design with me. Okay, if you are fail after your compilation is failed, my compilation is success. I will copy this C file to you guys. Okay. So then we look at timer initialization. Okay, what should be initialized under the timer? So this is something that is very important. So where should we look at it? So again, we have to go back to the where? To the timer config. Okay, the timer configuration special function register means that we are going back to this. Go back to the timer. Plus, is it okay? Is it so far everything okay? Come back to this timer control register. Okay, let's go through it one by one. Is everything okay? Some questions? I hope it's going smoothly. Okay, timer 0. Okay, of course, this one is to start the timer. You do the start or timer towards the end of the program. Remember, once the timer is start, you already start ticking and start calculating. Normally, we start at the end of the timer config. So, which bit we are using? Yeah, we are using 16-bit. Yeah, because 8-bit is not enough. 256, and then your counter will be very large. It's up to you. Okay, in order to calculate 1 millisecond, if you're using 8-bit, your counter have to be very large. To 16-bit, so I better use 16-bit. TOCS, I'm using internal. If you're using this, means you're as a counter how many, high to low to count up or count down. Okay, 0. Okay, so TOSC, actually it doesn't matter. Okay, because we are using this. Okay, so yeah, we can choose just 0 here. So PSE, PSA. So PSA is very important, whether you want to use a prescaler or non-prescaler. Okay, I will test you after this. If I use prescaler, you see what is happening. Okay, so let's say PSA, I use 0. So if you use 0, this one is not counted. So basically, that's all. Okay, so then let's say I don't know how to type the special function register. Never mind, I just copy this. Come back to our MPLAB X. Go to the big 18 definition. We Control V. This is the TCON. These are the TCON register. You see or not? So they define of union structure. I hope that you already understand what is structure and union. So structure means that this is fixed, the memory location. But however, we got two structures shared with union means it can be override, like top 0, 1, 2. You can declare by alone, or by just simply define this TOPS. 3 bits directly. Okay, what is the value? Let's say TOPS is 0x0B111, something like that. Or you can define individually. Okay, is it all right? Or you can directly using T0 cont. Okay, there's so many ways of writing this. Okay, example. So if you already putting in, the value, you can write T0 cont is equal to 0x 1, 2, 3, 4 or something like that, or 12 or something like that, or a binary 0 binary or 1011 or 0111. Okay, so this one is a bit, you need to calculate it, you need to do it first. But for me, so it'd be okay, it'd be good if you directly putting it and putting everything in so that the user can know what is going on. What do I mean? What does I mean? Means that I can using all this. Let's say I'm setting T0 8-bit example. Control C. I just put it back over here. Control T0 8-bit or is equal to 0. Okay, it's perfectly all right. I'm doing like this. Okay, like you can refer back. The TCOs. The next one is TCOCS. TCOCS. What is TCOCS? You can refer here, TCOCS, actually, okay, we don't care, okay? It's up to you, okay? If you don't put this thing in, means that by default, everything is 1. By default, if you don't set this, you don't set T0 cont, by default, everything is 1. They choose 8-bit for you. The transition is this one, increment high to low, you choose this for you, okay? Is it all right? So the second one is T0CS, okay, it's equivalent to 0 example, I don't need it. And then you can check TOSE, okay, 0 means internal, correct? This one, we don't care, Either you put or don't put, is all up to you. T0SE is equivalent, so it's equivalent here. Okay, so it's a bit tedious. You want to type everything, is all up to you. Okay, to tell the world that what is your setting. Let's say PSA. So PSA is equivalent to 1, no prescale. So it's 1. Okay. Okay. I think basically that's what you need to set, isn't it? Yeah. Yeah, that's what we need to set. Okay, so we don't have prescale, we don't need it. Okay. So then, so timer interrupt, then we have interrupt initialization. Okay, we do it nicely. For this, another one, interrupt initialization. So I think here is pretty okay. So then we come to here. So we have an interrupt initialization. I mean, just to be more, what have you initialized, to be more organized. So when you come to interrupt initialization, just now, you always come back to this as well. So you have to go to interrupt. So look at the table. So you need to, I'm using timer. Let me delete this. I'm using timer 0. Definitely I'm using this timer 01F. IE is to enable. These are the priority. Okay, and then GIE need to be on. Okay. For information, normally they use back the same word over here. Like say I copy this GIE. I copy this GIE. Yeah. So I want to check whether the reserved word is used in the XC8. Is it GIE or not? So I coming back over here. I come to this. Okay. So again, I have to find. It's a GIE. So it's GIE. Okay, it's a GIE. Okay, GIE. Okay, I'm not okay. Just GIE. So same. Come back to our program. Same. Just type GIE equal to 1. Okay. Then if you don't want mistake, I just copy this. This is to enable the timer. Yeah, cannot. Okay. It's 1. Okay. Then same. Let's say the overflow is, we reset the overflow in case this is just for safety purpose. Okay. Then we have a timer. Just now is what? Timer 0. TMR 0 high, is it? The timer low. Okay. So what is the value just now? We have the value that we have calculated. 0 F63C. Okay. I hope everyone is following. So then, of course, then we on the timer. TMR 0. Be careful with O, 0 and O are very confusing one, So that's why what I always prefer, I go back to the timer in order to prevent any mistake. I just copy this. Sometimes 0 and O are very, very, very confusing. Okay, so I on the timer. Okay, so you can do something like this. Okay, I hope things is clear over here. If yes, give me a thumbs up. I'm not sure whether it's very stressful for all of you. So let me know if you want to go to the a break or something like that. Okay. So everything is okay. So it's very straightforward. It's nothing to be hoo-ah about. Like example, if I don't put this thing in, what will happen? Can anyone tell me to have some exercise here? If I don't put this thing in, what will happen? What should be the value of this one? Can anyone tell me the answer? If I don't put this, what is the value of TMR 0 high and TMR 0 low? Okay, let me know. The first to give me, I give marks. Your name will be recorded. Make sure that is as a proof you post it, What is this value? Okay, let's have a short break to let you find out what is the value if I put PSA is equal to 1. And remember, we are using 10 megahertz. If I'm not using, I didn't put this. I ignore this line. I compile it. What should be the value of TMR 0 high and TMR 0 low by referring to this beautiful data sheets. Okay, let's have a short break. I know all of you already very tired. Okay, let's one first. Okay, I'm waiting for your answer. While waiting for my answer, I just copy this, into this Control C in case you miss out something, you don't want to type. Okay, you just want to test it. I put it over here first. Okay, there's already got one Yong En. Nothing's happened because the data sheet is already set to 1. Yes, the answer is correct. The data sheet already set to 1. So credits for you, Yong En. Okay, it's nothing's happened. You are right. Okay, let's say if I set to 0, tell me what is the value of TMR 0, high and low. Let's have a short break to give more chances for you. Actually, it's nothing happened. Why? Because when you reset here, it's already 0, correct? Not net 0. Okay, already 1, sorry. If you want to set 0 means the prescale is being assigned. Okay, so what will be the value of TMR 0 and TMR? It's very simple, it's very straightforward. Okay, let's have a short break. Okay, everyone is back. If yes, give me a thumbs up. And what is the answer? How to change the picture to pick F4550? I have chosen the wrong one. Over here. Device. Here. I wing with Wending. Okay, it's over here. You go to the spanner. You can choose any family you want. Okay, any family. Okay. Is it Wending? Okay. Okay, what is the if I choose 0, if I choose 0, so this means that this is 0. If this is 0, okay, if I don't put anything for my top 0, 1, 2, automatically it becomes 1, 1, 1, you know. Its prescale is 256. Okay, is it all right? So then you do the appropriate calculations. So I'm not going to discuss over here. So and of course, let's say if you put PSA equal to 0, there's few options for you to type, for these few bits. Example, these few bits. Let's see. You come back to the timer 0. Okay. Like for example, you want to set TOPS, you can always do something like this, just for C programming, just something on C programming. You can come to the MPLAB X. You can do something like this. 0 binary 110 example. Binary 110. Okay. You can do something like this. Okay. T0 PS, correct one. T0 PS. T0 PS. Okay, or you set it individually. Something like this. Okay, set it individually. Okay, so as we are not using the prescaler, we just ignore this lah. Okay, is it all right? So somebody asked me, since already reset to 1, why we need to write it out? So I know it's already reset. Once reset, it's become 1. But to write out so that you will show the user, to show your next time the person who's going to use this program, they know that you already reset this to become 1. Although after reset it doesn't become 1. Okay, is it all right? It is just for become the program, to make the program become more readable. Okay, probably we write some comment also over here. Okay, so I'm not writing comments today. So once the interrupt, everything is being done. So now it's the time to write the interrupt service routine. So again, you need to click into the MPLAB X, this C compiler. Okay, so let's say you don't know how to write the proper way to writing a C programming, C programming interrupt service routine. Okay, so once you click, you open, these are the thing, you search for interrupt. So it guide you to the interrupt page. Okay, the interrupt page. So you just scroll down and then, okay, they are using some example here. We just simply copy this, high priority or low priority is all up to you. Whether you set this as a high priority, whether you set this as a low priority. Okay, so you copy this, just put it over here. Okay. Okay. So, or whether it's high priority, it's low priority, it's all up to you. Let's say, I don't want high priority, I can just low priority. It's perfectly all right. Okay. So then the time to type your programming. Okay, come back to our beautiful flow charts now. So this is a timer interrupt service routine. The first thing you should do is doing the reloading to reload your timer. Okay, so we have a counter here. Okay, so we need to declare the counter. So remember, we use static because why? Every time it's coming in, the counter will not be updated if we define count to be 0. Okay, so if you don't have static, every time it's coming in, the count will be set to 0. Okay, then time to write your value, reload the value. Got this value, and then every time interrupt coming in, I will clear the interrupt service routine, clear the overflow flag. Okay, then just follow. So increment the counter by 1, increment the counter by 1. So I just count plus plus. Okay, then come back to here. So the condition is coming in. If counter equal to 3, doing this. If counter, else if, correct? So we just write our just write our condition code. Okay, let's say if count equal to 3. Okay, equal to 3. Okay, it doesn't matter. Is okay equal to 3. Then what should you do? Then I'm using duty 30, and you just say duty 30 is equivalent to duty 30 toggle this value. Toggle this value. Is it duty got no underscore? Okay. Okay, then we come back to here. Okay, else if 5, then we toggle. Else if else if the count equal to 5, then your duty 50. Okay. Or then again, else if count equal to 10, then your what's that? Your due if 10, then 110. Okay. Back to 1. Back to 1. Count equal to 0. Okay. Is it okay? COUNT, correct? What? Okay. So we have so this is how the interrupt service routines like. Okay, we go back to the main program. There's a main program, so we just main program is just after interrupt service routine, then you just say while 1. And let's say if you want, let's say we don't want to on the switch first. Let's compile the code. I think it's pretty done. Okay, before we compile the code, we have to ensure that we are using 10 megahertz of crystal. And you have to come to the project property here. So the simulator. So the FCYC, this is CYC, it should be divided by 4, it should be 2.5 megahertz. .5 megahertz, okay? After divided by 4 is instruction frequency, not the oscillator frequency. All right? Okay. So we compile and hope there's no error. Some of them. Okay, let's compile and see. Why cannot compile? Yeah, it's compiling. Okay, there's error. Why? TM0 where is it? Oh, I forgot semicolon. Okay, let's compile and see. Now I hope things is okay this round. Okay, the config work. So we need to put the configuration register in order to solve all this warning. So again, I told you already, you come to here, you come to debugging, come to target memory, come to configuration this register. Okay, so there's so many settings here. So for me, I just make sure that my workshop timer is off. Okay, I just off my workshop timer. I think all other things I remain it to be on. So I generate the code here. Okay, I just copy all these things over here. It doesn't matter. I mean, if you are not programming into the Picket 3 or Picket 4, you know, okay. Just to, if you don't like to see what I call that, the warning, and then there's some more warning there. What is this? Or some protected things is here. Never mind. So then we can hex code is generated. Is it generated hex code? Yeah, hex code is generated. And class, if you want, you know, after this you're going to port it to Proteus. If you want to port it to Proteus, it will be, you have to enable the COF file as well. This one is to load the symbol. To load the symbol means to load the assembly code lah. You want to see the assembly code, okay? So this one, under the XC8 global option, you should choose the COFF. So COFF file actually is to allow you to debug, you know, in this Proteus. Okay. And class, I already make a recording on how to use Proteus. Actually, you can port to Proteus by downloading the plugin. Okay, this plugin. Okay, by downloading this Proteus VSM viewer, okay, then when you compile, he will directly, when you debug, he directly going to the Proteus, you know, and start debugging. I have made a video on it because we run out of time, so I'm not showing over here. So you can try it at home, okay? But again, I tried this round. It gave me error because something wrong with this version of MPLAB X. I hope there's no problem, you know, with your MPLAB X, okay? And as well as you have to ensure that your Proteus is properly being cracked. Okay, that is very important as well. Okay, so let's debug this program to show that this program is really working or not. Okay, really functioning. So I debug it. So I'm entering into the debug mode. So in order to ensure to see that my program is really functioning, I need these few tools. Okay, you go to the simulator. First is logic analyzer, and again, I don't know why this round my logic analyzer is not working as well. So I'm not sure it works at your terminal or not. Okay, I will show you later. Okay, so let me close all these things. And the second things I need actually is a stopwatch. So these are the stopwatch. Okay, these are the stopwatch. Okay, so let's debug the program. The most important things here is whether it really 50% duty cycle is really 30% of duty cycle is generated, and I have to ensure that the timing is correct. So this means that every 3 milliseconds it will toggle, every 5 milliseconds it will be toggle. Okay, So another things I need is actually debugging is the watch window. Okay, I need to look into what I call that RD2 and RD3. I don't think so. Never mind. It's here. Okay, RD2 and RD3. Okay. So let's start debugging. So I put a breakpoint over here. Okay, let's put the breakpoint over here first. Okay, so look at the stopwatch. Where I run until here. So it took about 10 microseconds. So I clear it. Okay, so I single step means I already start running my timer. So by right, if I come into here, it should be give me about 1 millisecond. You see, 1.008 millisecond. So it's definitely correct. So this means that by using 10 megahertz, my interrupt is actually 1 millisecond. All right. So I remove this. This means that when I come into here, it should be give me about 3 milliseconds. Okay. Why 2? 2 plus 1 just now is 3, because it's the calculation is a bit weird over here. 2 plus 1 is 3. Okay. If I put here, it should be give me 221 is 5 milliseconds. Correct or not? 221 is 5 milliseconds. Or you can directly coming in as well. Like example, I can put my breakpoint over here. It should give me about 5 milliseconds. Not 5 milliseconds. So if you put a breakpoint, in MPLAB X, it's a bit funny. You put a different breakpoint, they will calculate, previous breakpoint as well. So it's 5 milliseconds. Okay. So I toggle this. So I come inside here. Is it 10 milliseconds? So it's 10 milliseconds. You see or not? So this means that it's really working. It's really functioning. Okay. So let's try this again. Let's say 30% duty cycle. When you watch here, so you come inside here, it will be toggle. Okay, you see or not? So it's toggle. Second time coming in, it will toggle. Okay. So is it all right, class? Okay. So this program is working. Okay, his toggle is 03 becomes 00. Okay, RD3. If yes, give me a thumbs up before we're moving to something that is more interesting. So I will copy this code for all of you. Okay, so you can directly copy into your design later. Okay, we have to move on because we are quite slow. These are the code. Yeah, if okay, if you want to move on, give me a thumbs up. Is everyone okay? So I have to ensure that everyone is going smoothly. And remember, don't have an attitude such that I will do it tonight. You have to solve everything now. Is it everything okay? I give you 5 minutes, to play around with it to ensure that the thing is really working. The debugging mode, is really functioning. Okay. And class, one more thing. Please look at here. Okay. So the logic analyzer, okay. For your information, by right, he should display 50% and 30% duty cycle in the graphical manner over here. Okay, I have made a recording, when I successfully did it for the past few years. Every year is working. I don't know why this year is a bit special. Okay, after I doing the update, so it's very simple. You press a setting. Okay, So I'm using LTD2 RDT3. So basically you just select RD2, double click. I've just put RD2, sorry, RD3. Okay. Okay. So the pin color, up to you, whether you want to use red color. Okay. Okay. So real time. Okay, you can, if you have a buffer size, I don't know, I can't even increase it. They fix it for 2000. Okay, the buffer size, everything is there. So save it. Okay, I'm using yellow and red. Save it. Okay, not only a save. Okay lah. Okay, so they create two graph for you. By right, you should toggle. Okay, by right, you should toggle. Okay, let's say I put the 50% here, and then run here. I don't know why nothing is displayed. Okay, it displayed perfectly those days. Probably my terminal got problem. Okay, okay, you can try at home. Okay, this is actually is a logic analyzer. Okay, or probably there's a real time. All this thing is there. I don't know. RDT2, RDT3. I put green, black color. It shouldn't be any problem. That's why, something free is no good. Okay, but however, when you put this into Proteus, it worked perfectly. Okay, so I give you about 5 minutes. Is it enough, or 10 minutes? For you to play around with this before we move to page 24. We also got Kawi Vision to play with. Okay. Stop this. I start the timer clock. Okay, so that you can play around with it. Okay, I give you 8 minutes. Okay, while this time is running, please you can ask me questions. Is everything okay? All of you, why so quiet? Let me mark the attendance first. Only 19. Everyone is in already. Very good. Class, say something. So I show my picture now. Yeah, please say something. Show something. Are you all still alive? Yeah, Lau Man Sing, are you still here? So can you repeat again the debugging steps? Okay, okay. Are your code but got error? How can it be? Unknown. Oh, impossible. I will send you the C file. Okay. Wait hand. Okay. Probably you just remove all this. Okay, it's the same. Okay. So I do the debugging again. Let's see how is it. Okay. Is it just Wei Hen got error or everyone also got error? I think that is strange. Wei Hen seems like everyone is okay. No error. Karin, Sirin, Fong, no error. Me got that error too. Okay, remove that. Probably our setting is different. Okay, you have to set your own. Why don't you generate it yourself? Let's say, why don't you generate this yourself? Don't copy my code. Don't copy my special function configuration register. Okay. Actually, that is mine. Okay, I don't know. Probably my setting is different. So your setting is different. Why don't you generate it yourself? Like for example, how to generate? I repeat. Go to Window. Go to Target Memory View. Go to Configuration bit. And the only one bit you need to change here is the watchdog timer. Just off it. Don't on. Off it. And generate. Copy this. copy, and Control V, paste. Okay, something like that. Okay, that will do. Okay, let's do the debugging again. Okay, I compile this file. Okay, I enter into the debug mode. Okay, so class, you see I'm setting, when I come to the running mode, is use hot at the main program. So how to do it? A lot of students, I'm not sure whether you're following me last week or not. You go to the option here, embed, this one. By default, it's run. You hot at main, okay? You hot at main, okay? So how to check? Let's say for example, one day you don't have a hardware, you just have a software to want to verify your code. After this code verification, only you put into the real hardware constructions. Okay, so it's very simple. So after you type a program, you need few tools. First is you go to the window. Let me close all the tools first, so that I can do everything from beginning. Okay, so you go to window. These are the tools that you need in debugging. Okay, so we need watch window to see the changes of your port. Okay, then we need a logic analyzer. Again, I don't know why this version is not working at my site. Might probably work at your site, because I don't know, because the MPLAB X is choosing types of memory, your computer specification, your computer requirement settings. I don't know why. So I'm using it. For information, my PC is about 6 cores, I don't know why. Probably I got many cores, they are not allowed me to run. Okay, so anyway, I have made a recording last year. I will post it to you. Okay, both, where I will teach you how to use the code configurator in the recording. I will teach you how to use the logic analyzer in the recording. Then the tools that you need is definitely something what we call that is where is my stopwatch. Okay, stopwatch is most important. Let's clear the thing. Okay, and remember, let's say sometimes you want to check whether my setting is correct or not for my timer 0, timer 1, all these things. You can always add the watch over here and special function register. And let's say, for example, I want to see my TMR 0 low. Okay, you can put anything over here. You see the setting is really changing or not. TMR 0 high. Okay, when the timer is on, it's really running or not. Okay, let's say I put it over here, timer 0 on here. Okay, see everything is 0. So I run until here. Okay, and my stopwatch show that my programming from the beginning till now, it take about 10 microseconds. Okay, so I come back to the watches. If I single step, my timer is on, and the TMLR low and high will start running. You see, I single step again. Is it start running? Do you see it's running? 43. You see it's running? Okay, so you can change the value here as well until you reach FFFF. Let's say F6. If I single step again, you see, you look at my while loop, single step F. Oh, okay, FF lah, FF low F2. So they will automatically F2 under FF, they will automatically enter into the interrupt switch routine 5 or also many times A 7 8 9 A B C D E F. You see, you will interrupt, F1. You see, look at the screen, look at about 1, you see 9 coming, going in. Why not going in? I don't know whether the debugging is correct or not. I mean, I don't know. It's on. Everything is on. Is it my workshop timer off? Off. Okay. So I believe there's something wrong with the not me, not my code. My code is perfectly all right. It's MPLAB X. I believe there's MPLAB X. So, but however, if I put a timer, let's come back to stopwatch. It's the same thing. It will work. Okay, when I come over here, I put a big point over here. My watch stop timer should give me about 8. Now it's 800 over. What happened? Did I change? Did I hold on first? Let me verify that the crystal clock you are using here is correct. It's 2.5 megahertz. Yes, everything is correct. What is changing my stuff? Okay, my stopwatch, I click it to 0. Okay, so I put my, let's say, where's my timer initialization? Okay, interrupt initialization. Okay, I make sure that my interrupt initialization is on. Let's say I put my pointer over here. I put it over here. Okay, it's 100. Okay, clear the thing. Take this off. Okay, so we come into here. It should about 1 millisecond is correct. Okay, so when I come over here, remember it's already calculated. You know, the 1 millisecond just now, it should be 2 millisecond now. It's 2 millisecond now. So you come into here, it should be 2 plus 1, 3. It should be another 2 millisecond. Correct or not? So it's 5 millisecond in total. Okay. If you don't want to do like that, you just clear this and you put a big point over here. Okay. Big point over here. So coming in is about 5 millisecond again. Okay. Okay, 10 milliseconds. So is it okay, class? Okay, you press reset. Okay, when I direct see 10 milliseconds, come here. So it's coming in, it's about 10 milliseconds. Okay, so I press reset. I put 5 milliseconds here. It should coming in about 5 milliseconds. Class, is impossible to get exactly 5 milliseconds. Because got interrupt service routine, got latency. You know, all these things is calculated. I put over here, I reset the system, it's about 3 milliseconds. So every 3 milliseconds is toggle. How to toggle? You can look at the watch window here, my port D, RD3. RD3 is 1, okay? Now I single step, becomes 0, RD3 becomes 0. Means it's really toggle, so means it's really correct. Okay, so this means that you can directly port this into the Proteus and run the system. So you can, okay? It's sure it's working, you know. Trust me. Okay, to prove that this is working, okay. Class, we will move to PIC 24. Now we can very simple. We can start the Proteus. Is everything okay, class? Always run the administrator. Yes. Okay. I just simply draw the PIC 18. You know, PIC 18. Okay. Just come on, faster, faster. File. New project. Yeah. So slow. I don't know what happened to my 6.4, so useless. Okay, then browse. I want to store into my pre-lab. Let's say 30 duty, 30, 50, 30. Okay. Hey, why select folder? Okay. Duty cycle, just simplify it. Okay, default. No. Okay. Coming out, so I just take out the PIC 18F4 4550. Okay, these are the things I need. Okay, it's in already. So probably I blink an LED up for 40%. Okay, I don't know, just chincai. Okay, so I take this out. Actually, you don't need all these things. Okay, let's say my reset, I always put it high lah. Okay, then you upload the code. Okay, I think it's a duty cycle here. You look for the COF file. Where's the COF file? COF file. Okay. And I just run it. I think I just run it. RD2 already blinking. See or not? Okay, how to do it? I just take out my oscilloscope. Oh, now let me stop this first. Where is my oscilloscope? Oscilloscope. Okay, my channel A go to which RD? RD what? I can't remember. RD 2 and 3, is it? I'm seen now already. Getting old. RD2 and RD3. RD2, where's RD2? Okay, it's RD2. This is RD3. Okay, run it. Other things is coming out already. I don't know why I can't enlarge these two. Okay, just okay now 30% and 50% duty cycle correct. Okay, so you can debug the software as well. Actually, from here, actually here you can pause it. The code is coming out for you. Okay, you can put a breakpoint here as well. Let's say duty cycle here, breakpoint, breakpoint, and breakpoint. Okay, then run it. Okay, you generated. Okay, by itself. Is it okay, class? So it's working. It's working. Am I going too fast and all of you already lost in the jungle? Okay, and don't worry, all these things I will already recorded. I give you a proper video. You need to have a look. Now is the time for you to try it. I give you 5 minutes, 5 to 10 minutes to try it. Okay. So that's why I say is we don't have enough time for the lab. So if I give step-by-step guidance. So class, remember, all these things is written, in our manual. Okay. In our practical manual, actually task 1, step by steps. All the step by step is over here. The pin diagram, 50%, what you do, 50%, watch it, breakpoint at different time, stopwatch, trace, or the logic analyzer, what you observe, all these things you can step by step, actually to follow. Okay. Yeah. Is it okay before we move to PIC 24? Actually, PIC 24 is our main target today, and CalU vision. Never mind, that one can be done within 15 minutes. It's very fast. Once you get the correct flow chart, everything become very fast. Okay. Class, any questions? Any problem you encounter? Wei Hian, is everything working now? Yeah, he said okay. Let's start. Man Sing, is you okay, Man Sing? Man Sing, okay. Jing Ching, Jing Sing, Lui Jing Sing. Who is Lui Jing Sing? I can't even recognize you. Jing Sing, are you still alive? Chi Pei, is everything okay? Just make it smaller. Nicholas, everything okay? Nicholas, okay. Junyuan, okay. Jing Hao, okay. It's very straightforward, nothing tough here. Jing Hao lost in action. Li Jing Hao, Jing Hao, where is Jing Hao? Already having breakfast, lunch, I don't know. Jing Hao, are you here? Jing Hao is not here. It's quite hot. I better switch off my camera. It's very hot. Okay. Jing Hao not here. Is it Jing Hao? It's attendance 19. Everyone is here. Jing Hao is not here. Okay, never mind. Okay, let's. Can I continue? If yes, give me a thumbs up. Can I move on? Okay, let's move on. Okay, class, now. You see, now we move to something more challenging. Instead of what I call that, PIC 18, we move to PIC 24. Okay, GS004. Okay, PIC 24. This is a PIC 24. So as I told you just now, it's very simple. Same thing, same process. We are using timer, only one timer 1. There's no timer 0. Okay, look at the timer block diagram over here. Very straightforward. This one is even more straightforward than just now. Okay, so now remember, let's come back over here first. Okay, if when you're using PIC 24, why is covered? If you are used, and normally the internal free FRC is OCR is 8 megahertz. We are using 8 megahertz. So 8 megahertz, remember, is divided by 2. Okay, the FCYC is divided by 2, so it's 4 megahertz. Okay, so in 4 megahertz, actually, the period is 0.25 microsecond. Okay, as simple as this. Okay, so let's look at the diagram. So everything is the same. Okay, let's say we're using timer 1. Let's look at here. Now it's the other side. I don't know why they are changing the other side. Okay, where is the input? So the input is here. So either you're using these two as an input, or you're using the clock itself. Okay, you see or not? TCY. So TCYC basically is equivalent to just now is 8 megahertz divided by 4 megahertz is coming in from here. You may choose this one, 8 megahertz divided by 2. Example, if I'm using internal FRC, this can be any value. If I'm using the preview internal crystal is 8 megahertz, so it's 4 megahertz coming in here. Or using this, this all the external, it's external input is all up to you. This one is, for example, as a counter. You want to check how many, how many person are entered to a library. You build a sensor there. They keep on calculating. Okay, Same, this is the gate synchronization, correct? Just now, same as just now. So of course, we are choosing TCYC, okay? So what is TCS, what is T-gate? So I don't know what is that. If you don't know, just refer to the table. So TCS is TCS or internal. I'm using internal clock. I choose 0, correct? Divide by 2. 1 is using external clock on the rising edge. Okay, so you're not choosing 1. 1 means that, as I told you just now, just like want to detect number of person go into the library. Okay, so every time you go to the library, when it writes, automatically they will increment the TMR1. TMR1 will be incremented. Okay, and remember this is 16-bit. It's not 8-bit because this is a 16-bit microcontroller. Okay, it's a 16-bit microcontroller. Okay, what is T-gate? Okay, let me class. You just go through a T-gate. Oh, when TCS is 1, the bits is ignored. Where is TCS? 1. When where is it? When 1 is ignored, when TCS is 0, then you have to use it. Get time accumulated enable. Get time accumulation is disabled. So this basically he will automatically accumulate the time, when it's running, keep on adding up. Okay, so never mind, we just have a look after this. Okay, so then what is so unique about this? Actually, this style is exactly same as timer 2 in PIC 18. But PIC 18 is 8-bit, this is 16-bit. Okay, now it's very simple. Whatever value you put inside here, okay, when I start the time, when T on, where's T on? When this time it is running, switch on. And of course, this is prescaler. So whether you want to reduce the frequency or not, okay, it's too fast, you reduce the frequency. If you don't want to reduce the frequency, just remain it. Just don't care, remain. So whatever value is inside here, let's say beginning, this is 0, 0, 0, 0. This will start running. Every tick is about 4 megahertz, 0.25 microsecond. You keep on running until the value same as this, then overflow will occur. And once it's occur, automatically the TMR1 will be reset back to 0, 0, 0, 0. You see or not? When equal, he reset it back. So this means that you do not need any auto reload like what we did just now in PIC 18. So clear, I repeat. Yeah. Delete. Okay. So I repeat. So this is just to on the timer. This one is external. We are going internal using 8 megahertz. Divided by 2 is 4 megahertz. So it's 0.25 microsecond. So every tick is 0.25 microsecond. Okay. This one is just for you to choose. Okay. So let's say tick is starting from the value 0, 0, 0, 0. When you start the timer, this one is keep on incrementing 1, 2, 3, and so on. So each tick is about 0.25 microsecond. Now your mission is put the value inside this PR1. When PR1 value same as the TMR1 value, it will trigger the interrupt, and at that time TMR1 will back to 0, 0, 0, 0. Okay, what is the value of TMR1? Okay, it's the same. It's much easier to remember. Let's calculate it out. I give you the answer so that you know how to do it in the coming task. 4 megahertz. So just now, actually, this one is give you about 0.25 microsecond. All right. So you want to generate the PR multiply by 0.25 microsecond, will give you about 1 millisecond. All right. So what is the PR? What is the PR? Is 4,000. So it's much straightforward. So this means that when you put 4,000 over here, you will generate 1 millisecond. Correct? So this means, okay, so this means what? This means like this, okay. Yeah. Why is keep on going off? Where is it? Let's delete this. Okay, so if I put 4,000 here, okay, this will keep on running. It starts from 0, 0, 0, 0 and running until 4,000. By using this comparator, it's the same. You trigger an interrupt and trigger an interrupt. At that time, 4,000 back to 0, 0, 0, 0. So this means that 0, 0, 0, 0 until 4,000. This time actually is 1 millisecond based on the calculation that we have just now. Ngamo, correct? The PR multiplied 0.25 microsecond equal to 1 millisecond, and PR is 4,000. So it's very straightforward. Am I right or not, class? So it's much easy. It's easier compared to PIC 18. Basically, PIC 24 is easier than PIC 18. Okay. Okay or not? Then, after that, same mission. How about interrupt? Yeah. Where is my stuff? Where is it? Okay, interrupt. Let's look at interrupt. It's much easier. Where is interrupt? Interrupt controller. Okay, same interrupt table, you know, all these things. And we have a vector number. Okay, same, you know, there's so many interrupt here. Okay, each have their own vector number. When you're in C programming, you don't need to care about it. But however, this table is very useful. Let's say I'm using timer 1. If you're using timer 1, means that the register that involved is this, you know, enable priority, all these register, special function register, you need to log into. Let's say timer 1 is IFS0, IE0, bit 3, bit 3, IPC0, you know, bit 12 to bit 14. There's a lot of special function register involved in this PIC 24. Okay, for the interrupt. Okay, this is the interrupt that is involved here. So class, they don't have like a master enable. I don't know. Don't have like high priority and low priority. So everything is predefined. Okay, everything is predefined. Okay, for information. So it's very straightforward. So you just need to enable that particular bit only. Let's say, for example, IFS0. So it involves timer 1 interrupt flag. So remember just bit 0, 1, 2, 3. Okay, you have to enable this particular bit, you know, for the interrupt flag. So you have to go. There's so many special function register. I'm not going through each of them. So how you use it is based on this table. Okay, sorry, your headache already if I'm going through like that. So based on the IFS0, we use it. IP0, we use it. IE0, we use it. Let's say, where is IE0? Okay, I just Control C, find IE0, next. Oh, you have so many IE0. IE0. Okay, then timer 1 enable, bit 0, bit 1, bit 2, bit 3. So we need to enable this. T1 IE interrupt request enable for timer 1. Is it okay, class? Okay, like you want to play around with priority IPC, I think IPC 0. Then the priority, okay, which one should be higher priority, lowest priority? You can set it, you can define it by yourself. Okay, is it all right? Then this is a priority. So, but of course now we don't care about priority. Okay, so then that's it. Okay, it's quite straightforward. Okay, then how about the interrupt code? How to write the interrupt code? Okay, same, you go to the microchip. Go to the convenient website. Okay, go to the microchip. And then you need to open the XC16 user guide. Hey, not this one. Which one? XC16 compiler user guide. Okay, and you also need interrupt service routine for XC16. This is a reserved word that you're going to use, like timer 1. So they have to use this reserved word. There's all many reserved word over here, and the interrupt vector number is over here. So we just use T1 interrupt, means it's a timer 1 interrupt. Okay. So coming back to this XC16 compiler, you just go to the interrupt here, and then this is how the way you are typing your code. Okay. So void underscore attribute auto PSV. I already learned if you're using a constant, you use auto PSV. So however, if you want to save the latency time, you normally use no PSV, no PSV. Okay, so this ISR is just the name of your interrupt service routine. Let's say, for example, if I'm using timer 1, just copy this whole thing and put it into this interrupt service routine 0 to your auto detected. Okay, is it all right? So if all this thing is fine, then we already start design our system, design our write our code, for MPLAB X16. Okay, are you ready? Ready? Give me a thumbs up. Yeah, Jinghao is okay. I know everything. Sometimes everything is disconnected. I hope you are not disconnected from me. Jinghao, give me a thumbs up. Are you alive now? Jinghao, a superstar, 3E superstar. What date? Okay, let's start the MPLAB X16. So I stop this. XC16. So new project again. Okay, next. So this time we are using PIC 24 FJ64 GA002. Okay, let's say 0002. Okay, can you see? 24 FJ64 GA002. Okay, we're using simulator. Next. Okay, so next. Okay, you are XC16 because it's 16-bit of C compiler. Next, and then I think this is a new one. Duty 24. So finished. Okay, same thing. I create a new file, C code, duty, pick 24, finish. Okay, so class, you no need to do much thing this round. Why? Because since you are using MPLAB X, okay, so if you're using MPLAB X, so this means that more and less is the same. Okay, this means that I can directly copy. I close this first. I compare a duty 50 just now. I copy all these things. Control C. I put it over here. Okay. Okay. Are you ready? Of course, there's a lot of red color. Why red color? Now we need to open up the PIC24 datasheet. GA004. Yeah, this is the one. Okay, this is what I opened just now. Okay, look at the specification. Of course, every time, first time you want to use PIC24, you have to look at the specification. So the beauty is 28 pin only. Just now the PIC18 is 40 over pin. You're so mafan. Correct? And the beauty of PIC24, why Utah like PIC24 so much? Because it's come in the dual inline package. Means that you can directly put into your beautiful blackboard. Okay, whiteboard you call it. Okay, but remember this particular thing is just 3.3 watts. It's a CMOS base. Okay, it's a 3.3 watt operating power, and if like GA004, it can where is it? The PIC24 FP6 GA002. This is the size of memory they're going to use. Okay, it's a tiny small small chip, if it's tiny small chip, input-output port is very, very expensive. I can say that, very variable, okay, because it's very limited, okay. So remember, they don't have a RD, don't have RD, port D don't have, it just have port, what port A. And remember, most of the port A are sharing with analog pin, and port B only, okay. So that's why we need to do a bit of adjustment of the input-output pin. Is it okay? Okay. Okay. So let's come back. Let's say we are using same line. We always go towards the end. RB6 and RB7. Okay. Okay. Or up to you lah. Okay, 6 and 7. You see, like why I choose 6 and 7, because they don't have an analog pin. So be careful. Be careful when it's sharing of analog pin. You have to ensure that, okay, this 2 pin is set to become a digital pin and not the analog pin. By default, it's analog pin. Remember this. Okay, if you don't believe me, you can have a look here. Analog digital converter. Where's ADC? I can't see. I'm already. Where is ADC? Yeah. So by default, everything is set as where is it? Okay. Now is icon 0, icon 1. Then by default, everything setting here is 0. Press 0 means that it configure as analog pin. But if you want to use that pin as a digital pin, you have to set it to become an input-output. So this means that AD1 PCFG better equal to 0xFFFFF. If you plan not to use analog, not to use any analog input, just for information. Okay. Timer. Okay. Let's do our settings. Okay. Come back over here. So this need to be changed. We cannot use LTD. So let's use I don't know. Just now is 7 Chincai lah. LTB7, LTB8. So what's the time now? Oops. Okay, same thing. Initialize I/O. So when it initialize I/O, this one what I call that? We are using tries B. B7 tries B. Notch a bit. Okay. Okay, same duty 30%. Okay, same. Okay, so timer initialization. Of course, timer initialization need to do a bit of update. Okay, so we go back to the timer. Okay, so the register involved is not many. It's just these few bits only. Okay, so T on. Okay, have to be on. Okay, so if you're not sure, then you copy this same process what I did just now, and then open the xc.h again. Okay, and pick 24. This is much easy. Okay, this is the one. Navigate. Okay, then let's say I want to find this T on. Okay, T on is here. Okay, there's so many T on. So T on is being defined underscore, underscore. Okay, I can use underscore. Okay, So same with other bits. Okay, so this means that we can start our writing as well. Come back to a peak 24 duty cycle. Okay, so timer interrupt. So we no longer using all this. It's no longer applicable anymore. All right, or not? So just now still remember, the first thing we should put in is the PR1, correct? What's the value we calculate just now? 4,000. Equal to 4,000. Okay. And you have a timer 1 interrupt flag is equal to 0, correct? Okay. So and then let's check whether it's correct or not. T on is to on. T gate we don't care. We don't care. We don't care. T sync we don't care. What is TCS? TCS is 0. Okay, TCS is equal to 1. I think that's all. That's all. Okay, that's all. Not many setting over here. So TCS and some more TCS by default is already 1. Am I right? TCS by default is 0. By default is 0. It's already 0. Okay, never mind. You just put it 0. Okay, that's all I think. Okay, then probably you on the timer. Okay, on the timer. Okay, so how about the interrupt? Probably initialize the interrupt before you on the timer is better, you know. Okay, it's more accurate, so this one need to be going up. Cut. Over here is the same lah. Doesn't matter. The arrangement is not important. So we don't have GIE. We don't have all these things, you know. Okay, so we timer enable, you know. I think it's T1 IE. This one is T1 IE. Timer 1 IE is on, and then put underscore. Okay. Yeah, it seems okay. Let's check whether it's correct or not. Timer 1 enable. Okay, so you can check from here. And it's correct. You know, T1 IE. Okay, T1 IE. T1 IE is a T1 IE IEC const. Remember just now, it being declared correctly. Okay, so it's same with this also. T1 IF. Clear the timer overflow. T1 IE. T1 IF. Okay. So I think basically that's all. We don't even need all this. So we just need to enable the interrupt only, correct? T1IF. Okay, so it's so straightforward. Okay, we've done everything. So then we need to change the interrupt over here again. Come back to this file, the XC16C compiler. And I just copy this line, Control C, and come into here, Control V. Okay, so I'm using interrupt 1, correct? So still remember we have a config bit just now. Where is it? Copy. Okay. So whether it's auto PSC, no auto PSC, I think basically that's all. We don't even need all this because it's auto reload. Okay, we don't even need all this thing. We don't need all this. Why they got error here? Oh, semicolon. Okay. Yeah, static unsigned count plus. Okay. Probably coming in you had the timer 1 overflow I deleted. The timer 1 overflow need to be set because you don't know how to auto reset it. Okay, so you don't change anything over here because this is a skeleton program. You don't even need to change it. Okay, so I think basically that's all. Is it straightforward? It's quite straightforward, isn't it? Okay, so then while one, yeah, everything is okay. Initialize IO, timer interrupt is initialized, timer initial, okay, IO interrupt. Okay, let's compile it. But of course, there's so many error here. Undeclare, how come undeclare? LATB need underscore. I think need underscore, is it? I think so, need underscore. Okay. Okay, and one more thing, you need to change the frequency. So we are not using 1 megahertz. Just now, what is the frequency just now? Is 8 megahertz, is 4 megahertz. And of course, we need to generate the what I call that, the configuration register bits if you want. So two things need to be changed only is the to disable the watchdog timer of it. Okay, but if during compilation, actually this is don't play any big rules lah. You just off this. Okay. What else? Okay, we are selecting internal FRC. Okay, 8 megahertz lah. Okay, then generate the code. Then just copy this. Class, you only did this code when you come into the real world. I mean, you want to program into ticket 3 or ticket 4. Okay, let's compile this again. I still got error. My initialization typo error. Okay, this all underscore. Okay. Compile again. Yeah, it seems working now. So you perform the same thing. Okay, so you come into here, you go to debug mode. Okay, we open our stopwatch. Okay, let's before the timer is on, we put the things over here. So we come into here. It's about 1 millisecond. Okay, single step, let it run. Okay, clear it. So it come into here by right, it should be 1 millisecond. Okay, 1 millisecond. So it's perfectly correct. It's perfectly all right. Okay, so I double click this. I reset the system. Okay, when I come into here, it should be give me about 3 milliseconds. 3 milliseconds. So I reset the system. When I come into here, it should give me about 5 milliseconds. 5 milliseconds. Okay, so reset the system again. Now I want to come into here, it should be give me about 10 milliseconds. 10 milliseconds. So it's perfectly all right. All right or not? Okay. Is it okay, class? Okay. So the same thing actually is applied in any microcontroller. So what does it mean? Means that you cannot port this, but we can port the skeleton. This is the brain of this program, isn't it? This is the most important thing. So this means that this particular drawing here, the flow chart, it can be applied in any situation. All right, any situation. Okay, so is it okay? Class, if okay, give me a thumbs up. Why Wing sounds so sad? Is it too tough or what? Okay, don't worry, I copied this code for you guys. Okay, I copy. I know there's we don't have much time left. Okay, I've got another things to show you. And there are a lot of video. I already make a lot of video. You can try at home actually. So this is the whole program of this thing of this using Pick24. Okay, so it's not difficult at all actually to write a program. Okay, so is it all right? Yes, give me a thumbs up. Okay, who is still not sure? Is it okay? Is everything okay, class? I hope that you are using this weekend to try. You need to try. I know that you don't. It's very difficult to do it, synchronously. Or today, 4 o'clock, you can come back and ask questions. You can try at 4 o'clock. Okay. So the last thing, let's migrate this something that is not microchip. Okay. Something that is example. We are using CowU Vision. Okay. I give a short break of 5 minutes. Okay, so that we move into the CowU Vision. Okay, any questions from the floor? Let me know. I give you to compile this, run this, so that it's really functioning. So there is not much things over here. Yes, any questions? Yong-en, is it okay? Yes. So you need to try, you need to try all these things, during, class, all of you, if you are free, just come to my 4 o'clock. I give an additional things and we discuss about the assignment as well. So any questions from the floor? All of you already lost in the jungle? Still got 15 minutes. Okay, let's try something. Okay, class, is everything okay? Is it okay, class? Why no response? How about others? Okay, you may try. Okay, class, now we move on. Okay, let's say we are trying something more exciting. Okay, so, okay, you see, just now we are trying everything is microchip. Let's try AdMail, and class for information. AdMail already bought over by who? By this microchip. Okay, so this is an AdMail microcontroller. It's an 8-bit microcontroller. So those there, AdMail microcontroller is a very popular microcontroller because they are adapting MCS61 family. So again, here are some of the info of this microcontroller. It's very simple for simple job, for simple tasks. It's not as complicated as microchip. This is considered a grandfather of a microcontroller. It's an old microcontroller, but however, it's still very popular till nowadays. If you don't believe me, you can go to the microchip website, select AdMail, and you can find this AT89S8253 microcontroller is still in the production line. But of course, today we are doing the same thing. Same thing like you are doing a 30% and 50% of duty cycle. But however, we are using different IDE. If you're using this micro U vision, you will realize that why I don't really fancy MPLAB X. I like how U vision. Okay, for your information, those days when I'm in industry, I like how U vision very much. I'm using it. Those days when I'm studying my master in UK, when I work in some of the company in Germany, they are also asked, us to use CowU Vision because it's a very user-friendly. I tell you that why it's user-friendly. Okay, but however, let's look at AT89S8253. So same, look at the timer. These are the timer. Okay, these are the timer. We got timer 1, timer 2, timer 3. Is it timer need to refer to this particular document? So I already downloaded it for you guys. These are the document, if I'm not mistaken. It's the same. Okay, so basically it's a very simple timer. Where is it? Why I can't find timer? One. This is the one, isn't it? Yeah. Okay. So let's use timer 1 now. So this is a timer 1. Okay. So they got a 13-bit mode. We are now using 16-bit mode. Exactly same like PIC 18. Okay. So the interrupt, this is an external interrupt. So there's a pin here, counter or timer. So you choose timer, we switch to 0. You choose counter, you choose 1. You can see from here. Okay. Choose 1 means you're choosing this. You choose 0 means you choose this. Okay. And remember, all the clock is coming into AT89S8253 is let's assume I'm using 12 megahertz and divide by 12 coming in is 1 megahertz. Okay, I'm selecting 12. So, and actually it's about 1 microsecond. Okay, so normally the most popular frequency is 11.0592 megahertz. Okay, and it come out at 1.085 microsecond. This is the one I always use last time because this gives you a very accurate bow rate when it comes to UART communications. Okay, so this is what we are using an 8-bit mode, 8-bit auto reload mode. Let's say we are using auto reload. Auto reload means we don't need to reload our timer anymore. Okay, so you don't need to reload our timer anymore. So it's up to you whether you want to use auto reload or not auto reload. So here are the special function register. Is very straightforward. Just a few bits on it. Timer overflow. Start the timer. Timer overflow for timer 0, timer 0. Interrupt. Okay, this is just an interrupt. Okay, so it's just as simple as this. Okay, it's just as simple as this. Then they also got T-mode register. So T-mode register, if we are using 01 16-bit timer. Okay, we are not using 8-bit timer lah. We're not using all this. We are not using auto reload. We're using 16-bit timer. If you're using auto reload, it's just an 8-bit timer. He can auto reload itself. You no need to reload your value of timer high and timer low in the interrupt service routine. Okay, so this one I will set it as timer low. Okay, so this one all we don't care. We are using mode 1, 16-bit of timer. Okay, so it's quite straightforward. So then if all this thing is here, then we can start writing our program. But before writing a program, we should also look into the interrupt. So interrupt is very straightforward. Basically, these are the interrupt. EA is a master interrupt, just like a GIE to enable the interrupt. So this one need to be on. So this is the external timer. This is timer 1, timer 2. So you want to another timer 1 or timer 2 interrupt. This one should be on. This is for timer 0, timer 1, and timer 2. Okay, just ET1 should be on. It's more or less it's the same for all the microcontroller. This is just a priority. Okay, you want to arrange a priority. So basically for AT89X8253 is very straightforward. This is level 0, level 1, level 2, level 3, level 4, level 5. What does it mean? What I mean is like this. If you are using timer 0, okay, the compiler only identified by the number is something like this. So I can say that void timer 0 interrupt. Okay, can be any name. So towards the end here, I just put interrupt 1. When I put 1 means that I'm using timer 1. Not like in your microchip, you need to identify your so lengthy, interrupt 1 or timer 1 interrupt. But for AT89S8253 is very simple. Interrupt 1 you do. Okay, so that's all. That's all. Then we can already start writing our code already. Okay, we make it quick. Okay, we close this. We start our CowU vision with our CowU vision. Already writing something yesterday. Okay, so we close this. So project, we create a new project. Okay, we go to the desktop, we come back to download. Okay, pre-lab again. So duty 1. Okay, save. Okay, so sorry. Project, new project. 1, save. Okay. Why all my things gone? Okay, so I'm using microchip. It's still microchip because microchip already took over the ML AT89S8253. Okay, this is the one, all the information is over here. Okay, and class, remember, they support so many different type of a microcontroller. Okay, same. So then I just, as usual, I create my .c file. I save as duty.c. Okay, I just need to add the file. Okay, now I already added. Okay, let's just add the file. Add the existing file. Sorry, it's add the existing file. I recreated just now, duty.c. It's added. Okay, so it's very straightforward. Just right click, you can create the header file for you. No need type xc.h. Okay, so now we import the files over here. We just come to MPLAB X. We copy everything over here. Okay, Control C. So remember, of course, it's not working. Why? Because you cannot put some of the information. Some of the information like what, like tries B, this is does not exist, in PIC 18 at all, 8089S8253 at all. So same, a little bit of changes over here. We don't have LTB8. Okay, so instead, if you look at the 8089S8253, the pin configuration is just port 1.0, 1.1, 1.2. They are using port. Okay, so to define this is a way of writing. Just write port 1. I enlarge this for you. Port 1. Now I need the cap bit 0 example. Port 1. Okay, I create bit 0 and bit 1 for me. Okay, so this initialization, I can preserve it. Okay, we don't have tries in or out. Okay, I just want to do one initialization, just do one go lah. So I just do everything in because we're running out of time. We just ignore all these things. We combine everything together. So we combine everything together. Okay, so first of all, we need to assign, let's say, the timer flow 0 equal to 0. Okay, its overflow is 0. TH0 is equal what value? What value you need to load inside? Basically, we have to redo the calculation. This calculation is, we are using 0.4 microsecond. So basically, in in AT9S8253, we are using 65536 minus, what is this? Multiplied by 1 microsecond equal to 1 millisecond. Okay, so I already calculated just now. It should be 0xFC18. So that is the answer. Okay, so I don't have time already. Okay, let's say 0xFC. I can buy some time from you, 0x18. Okay, so and then of course, just now, if you remember, we have a few things need to be configured. One is a T mode. Okay, one is the T mode register. One is the TCON register. All right, we got T mode and TCON register TCON and T mode register. So T mode, actually, we are using timer 1. We just need to set this 01 for timer mode 1, 16-bit 01. So this should be 01. Okay, so this should be 01. Okay, so for timer 0 so 01. So it's just T mode is equal 0x01. Okay, so then I should enable my timer interrupt, and I should enable my master interrupt. Then I start my timer. Just as simple as this. Okay, initialize IO. Okay, we don't need this anymore. I put everything in. So we don't have this attribute like what I told you just now, but however, we have a what I call that, the interrupt. I just give it any name. Any name will do, let's say timer 0 interrupt switch routine. Okay, and then let's say then you got, this is the reserved word, interrupt 1. Interrupt 1 means timer 1. Okay, based on the hierarchy which I show you just now. Where's the hierarchy? This hierarchy. Zero, one, timer 1. Okay. So basically that's all. So overflow means it's timer 0 overflow. T 0 is 0. And reload the timer. Reload the timer because it's reloading. Okay. So count plus, I think all these things and more or less is the same. Okay, let's compile it. Okay, it's 30% and 50% duty cycle will be generated. Of course, I will put the option here. I'm using 12 megahertz. Okay, 12 megahertz. Okay, just right click here, target, right click, option 12 megahertz. So I compile this. Hope there's no error. Oh dear, why got there got error? Why so many error? Where is the error? If count is equal, what's wrong with this? Count equal duty, so it's correct. Where is the error? Interrupt 1, static, unsigned child, same, TF0. Okay, no problem. Okay, no problem. No problem. Where is the error? TF0. Correct. MS count plus, correct. Count duty. It looks okay. Where is the error? It's okay for me. Else. Looks perfectly alright for me. Is it something I didn't set properly? Static unsigned child, interrupt 1. Okay, should I declare this at the top? Okay, I don't know what's wrong actually. Some typo mistake that I can't see. If count equal to 3, that's correct. You didn't change anything. Count plus, count equal to 0. Else if count equal to 5, correct. Any typo mistake, any semicolon I ignore just now. Anyone? Expect syntax error, some comma, what comma? Duty 50, duty 50, correct. 1.0, so it's correct. Okay. remove this again. Okay, then an existing file. Delete C again. Where is the error? Anyone? Okay, I think see you next time. Bye bye. Sorry for the delay. I will let you know what is the problem. I will post the correct code to all of you lah. Okay. So and I will post a lot of what I call that, a lot of video so that you can practice it during this weekend. Okay. Sorry for the drag, the time extension lah. Okay. I will let you know what's the problem. Okay. Probably if you got time, you can always come over this 4 o'clock. Okay. Okay. See you. Take care. Bye bye. You may leave now.